It's not uncommon to get information from two or more different sources, and that information doesn't always agree. A good example would be if I'm driving. So I'm in my car driving around, and maybe I have my maps or Waze program on telling me which way to go, turn left, turn right, and so forth. But if the person in the passenger seat is giving me different information, what am I to do? I've got to make a decision. Either listen to the passenger, follow the instructions, or do something completely different. Well, a Cisco router has the same challenge. It can be learning routes in different ways. It can be directly connected to networks. It can dynamically learn networks via dynamic routing protocol like OSPF, or the administrator could statically configure routes, or we could use software-defined networking and programmability, and we could have automation program static routes on that router. Regardless, if the routing information is conflicting between these different sources, what is a router to do? In this video, I'd like to share with you exactly the decision that the router makes about which of those routes it's going to put into the routing table so it can then go ahead and use it. And as a reference point, let's use this network. And over here, let's imagine we have the 10.2.0.0 network with a 24-bit mask. Now, router 3 could learn about that network lots of ways. It's not directly connected to that network. It's way over here. But we could have static routes that tell this router how to forward to that given network. Or we could have some dynamic routing protocols like OSPF or similar. And so router 3 has to make a choice. OK, which of these routes to 10.2.0 am I going to put into my routing table and actually use? Because it only wants to choose the winner. It wants to choose the best route to get there and put that single route in its routing table. And here is the King Kong of decision points as far as which route is going to be best. It is going to be the one with the lowest AD, the administrative distance. So if OSPF is advertising that network with an administrative default distance of 110, and RIP is advertising that same exact network with a default administrative distance of 120, and we have a static route, and a static route would have an administrative distance of 1 by default, but if we put that at 125, this router, as it considers all that input for the same exact network 10.2.0, it would say, well, based on the lowest AD, that's the one I'm putting in my routing table. And so then, bing, 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 the router says, well, I have all these three choices. The one with the lowest AD, the lowest administrative distance, in this case, is the one learned via OSPF. That route and that route only is what I'm going to put in my routing table. It's the winner, and that's the route that's going to be used for that destination network. So in this scenario, the route that was learned with an administrative distance of 120 and the route that was learned or configured with the administrative distance of 125 are both not being used because the route with the administrative distance of 110 had the lowest AD. Now, what if we are learning the route 2 times via OSPF? Maybe we're learning it coming in from R1, we're learning it coming in from R4, and heck, let's do it a 3rd time. And we're learning it coming in from R2. We have OSPF neighbor adjacencies with all 3 of those routers. We're learning the same exact network 3 times. Now what do we do? Especially if the administrative distance is 110 on all 3 routes. What's the next tiebreaker? And the next tiebreaker is the metric. And in OSPF, that metric is also known as cost. Meaning, which of those 3 routes that I'm learning about, which of those would be the least expensive, the least cost routes? And here's a secret that you and I can use to help us remember which routes actually make it into the routing table. And the answer is, you have to get up pretty early in the morning to figure out which route goes in the routing table. What do you mean, Keith? You have to get up pretty early in the morning to figure out which route goes in the routing table. The acronym I'd like you to remember is AM. You have to get up pretty early in the AM to figure out which route to put in the routing table. And now that we've said that a few times, let's talk about what AM means. And AM represents the pecking order. Administrative distance first, and the route that has the lowest administrative distance is going to win. And if we have 2 or more routes with the same administrative distance, the tiebreaker is the metric. Or in the case of OSPF, that's referred to as the OSPF cost. So the router gets up pretty early in the morning, AM, to figure out which routes to put in the routing table. It uses AD first, and if there's multiple routes, exact routes with the same AD, it then takes a look at the lowest cost to choose the best route to put in the routing table. And a common question that comes up, especially for the router, is what if I have 2 routes that were learned, they both have the same administrative distance, and they both have the same cost? Well, the good news is those would be equal cost routes, where the route for that network has the same administrative distance, the same cost, and then with those 2 equal cost routes, it can put them both in the routing table, and then it can load balance across both of those links. And that's how it handles equal cost routes on a Cisco IOS router by default. So I'm glad you joined me in this video on identifying how the router decides which is the better route. And in the next nugget, we'll go ahead and take a look at a lab to help reinforce the concept about which route makes it into the routing table by doing some hands-on configuration and seeing the routing table change right before our eyes. So I'll see you in that next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.